Hello, everyone. My name is Assencio. I am a solutions engineer at GitHub, and I'll give you a presentation today about GitHub Codespaces. But before I start with the technical stuff, let me quickly introduce myself. As I said, I'm a solutions engineer, but I didn't start my career in the software development industry. I actually started as a physicist. And as I was doing a PhD in physics, I started to realize that professionally speaking, software development is my greatest passion in life. So when I finished my studies, I started working as a software engineer. And over time, I took on roles such as engineering manager, project manager. I was even a scrum master once, which was a lot of fun. And throughout this career path, I could see how much progress we have made in the software development industry. And I don't mean only in terms of tools. Certainly, the tools have evolved greatly, but also in terms of ways of working and our values towards software development, our processes. We have come such a long way. And really, tools and ways of working evolve together. When we discover better ways of working, we also realize that there are good opportunities for automating certain tasks that are necessary in order to follow that path that make us all more productive, increase developer satisfaction, and really increase the quality of the code that we all create. So with that said, I want to quickly go over the Gita Flow with you, and let's look at which steps of the software development lifecycle are already pretty good in terms of automation, or at least I should say have very good solutions for accelerating development and taking care of certain tasks for us in an automated fashion so that we're all more productive. Let me quickly share my screen. Just give me 1 second. There we go. So what you're seeing now is the Gita Flow. So imagine that somebody comes to you and say, hey, there's this feature that we need to implement, or there's a bug that needs to be fixed. And as a software developer, the first thing you're likely going to do is create a branch where you can work. And I do hope you create a branch and you don't make your changes directly on the default branch, because that's usually where the production-ready version of the code lives in. And if you make changes there and break things for everybody, you're going to find out that that's not a very good way to make friends in your team or in your organization. So creating a branch is a very typical way of working. And we start by creating commits, exploring, trying things out. And at some stage, you will get to you will grow some confidence and realize, okay, this is a good moment to share my code with everybody else and let people jump in and collaborate with me and, I don't know, make changes, request changes, make suggestions. So you create a pull request. During the pull request phase, there's going to be a lot of conversation and collaboration among really everybody who is interested in in your work. So it doesn't have to be a software developer. It can be a project manager, a product manager, really anybody who is interested in the work that you're producing here. After that, you have the option to deploy your code to for example, a test environment where further tests will be conducted. And when everybody's happy with the results, everybody's confident that the code is good, that the feature or bug fix have been developed in a proper way, you can merge these changes back into the production-ready branch, your default branch. Now, going through this, you can see that this is basically a story of the software development lifecycle in terms of build, test, deploy. And let's look at which parts of this whole path have tasks where we already use automation. So for example, when you're committing code and you push your changes to GitHub, you may already be executing automated tests that will give you early and fast feedback on whether you have broken another feature of the product, which is definitely not what you want. Perhaps you have by accident introduced a security vulnerability. So it's always a good thing to have some form of automation give you quick feedback on the changes that you are making on the code. And this also applies to the changes that happen during the pull request phase, right? If you're reviewing, making changes on the code, again, you want to have some form of automation give you fast and early feedback so that you can fix whatever has been broken. And it's always cheaper to do things at this stage than after you have deployed your code to a production environment, for example. So again, deployment, lots of automation happening here. I'm pretty sure you're very familiar with them, with the tools that are used at this step. And even after you merge, you may think, okay, automation is over, but not quite, because you merge. And at this stage, you may, for example, start the deployment in an automated fashion to the production environment. Or, for example, you may have a monitoring solution which is constantly checking the health status of your servers and making sure, for example, that your application is running properly. And if there's too much load on the servers, perhaps activate new servers so that you can better load balance the incoming traffic, for instance. So, I mean, the message here is really there's a lot of tasks that are automated throughout the software development lifecycle to make us all more productive and really to increase the confidence that we have in the changes that we're making. But we very often overlook this step here. And I don't mean creating a branch, because I'm pretty sure everybody here can create a branch very quickly. And you perhaps don't need automation for that step. But I mean really setting up the development environment where you can do your work. Because really, if you are a new employee and you received your laptop from IT, great, you have a laptop, but you don't have a development environment. You're going to have to install an IDE. You're going to have to install a bunch of libraries, packages, system tools, set up some environmental variables, for example, so that you can properly compile your code. And really, there's a lot of work that needs to be done before you can actually start writing code and actually start producing value for your organization. So this is all very expensive. In some cases, it may take you weeks until you have your development environment fully set up to do all the work you need to do. And the question then is there anything you can do to improve the situation? Can we automate the setup of the development environment? And the answer is yes. And the answer is GitHub Codespaces, which you're going to start seeing now. So just give you 1 second. All right, so the repository you're seeing now is a public repository. So if you go to github.com/theassencio, which is my handle, /codespacesdemo-python, you're going to land here. And this is a repository that I'm going to use for this presentation today. It contains various code space definitions. And really, the important thing to realize here is that a code space is defined as code. So you can really call it development environment as code. Meaning, if you have different repositories that you need to work with, you can really set up a code space for each of these repositories, which is optimally designed for developing code for that particular project. So if you have, for example, a C++ project, but you're also working on a Python project or, I don't know, a JavaScript project, you can create different code spaces which are really optimal for these programming languages with the right extensions, with the right configuration, libraries, packages, and so on. I will switch now to the default branch. And the default branch, as you can see here, only contains a single file. It's a README file, meaning it has no code space definition whatsoever. And the reason why I'm here is because I want you to see what a code space looks like without any configuration. So a truly vanilla code space. And for that, I'll click on the code button here, open with Codespaces, and then new code space. It's going to take a couple of seconds to load, but it's pretty quick. And we're going to get an environment, which is essentially Visual Studio Code running on the browser. And this instance of Visual Studio Code, it will be connected to a Docker container running on a virtual machine hosted by GitHub. And this Docker container is where you would, for example, install your libraries or packages and everything else. And that's where also the code lives. So the complete picture here is Visual Studio Code running connected to a Docker container running somewhere on the cloud. And that's where you're actually going to be doing your work. So again, look at this. This is basically Visual Studio Code as you're already familiar with, and I hope you love it as much as I do. I'll go to the README file so you can see, for example, you can edit files. If you make a change, there's source control, and you can commit your changes directly from here to GitHub. There's not even need for authentication because you are already within GitHub. What else do we have here? So install an extension and so on. If I go to the terminal, I can quickly, out of curiosity, check what is the operating system on the Docker container. So this is Debian 9. Great. And yeah, I mean, this is already a very powerful editing environment. With zero setup time, I already have something that I can start working with. I could, for example, use a code space, this is the vanilla code space, to actually define more complex code spaces, or really just do all my code editing here. But again, this is only so that you get the feeling of what a vanilla code space looks like. The real fun is ahead of us. So let's switch to a more complex code space. So our second code space example is a more complex one because this time we actually have a code space configuration. So for that, I've already switched to the simple branch. And as you can see, we have more files than in the previous example. Octocat.py is a Python script, which you can think of as the application being developed here in this project. Requirements.txt is a list of Python modules that need to be installed so we can develop this application. And the actual code space configuration is located in the .dev container directory. So let's go inside and see what we have there. So two files. Devcontainer.json is where the high-level configuration for the code space is located. So we're going to look at this one first. And here you can see that we first specify the Docker file that we wish to use to provision the code space container. And this Docker file really is the one that you just saw here. Yeah? So we're going to look at this one later. So back to devcontainer.json, we specify the container for Docker. An extension here is Python. That's the only extension that I'm going to install in the code space automatically. And all of the settings here are injected into Visual Studio Code. And this makes it really easy to set up Visual Studio Code already out of the box in the way that we want. So for example, here, I can specify a formatter for Python, in which case it's black. I like black because it's highly opinionated and I don't have to think about any of the configurations. For example, for the formatting settings and everything, black is basically telling me I want your code to look like this, and I'm fine with that. Makes life easier. And launch is a launch task for Visual Studio Code, which is going to initiate, start the debugger, and the debugger is going to initiate this script here, octocat.py, which we just saw, and it's going to stop at the very beginning of the script. So this gives us time, for example, to select a line as a breakpoint and act as if you were debugging the script. So let's check the Docker file. So here's Docker file. It's rather simple. We start with Ubuntu, and I update the package lists inside of the container. I upgrade packages, and at the very end, we install Python 3 and Python 3 pip. So I need pip because I need later to install the Python modules that are inside the requirements.txt file, which is precisely what these last two steps do. So first, I copy requirements.txt into the container, and then I use pip to install the Python modules that are listed there. Okay, so I could, at this point, go to code, open with Codespaces, and start a new code space. But just to make things a little bit faster in this presentation, I already initialized the code space. So now that we're inside of this code space, you can already see the project files on the left side. And octocat.py, as I said, is the Python script, which is the application we're developing in this project. Because we have already installed the Python extension for Visual Studio Code, you can already do operations out of the box, such as jump into the symbol definition or refactoring. So let's see, for example, if I click on traceback, I can already, I'm taken to traceback.py automatically, so this symbol recognition is working. And I can also do things such as right-clicking on a variable and renaming it, for instance. So really, the operations that you're familiar with the Python extension for Visual Studio Code are going to be available here as well. So let's see what the script actually does then. We call the octocat API using URL-lib. And I'm going to show you what the response looks like in a second. But what matters here is that we're going to get a response as HTML and print it. That's essentially what the script does. There's some error handling here at the bottom, but this I hope is not going to be important for us today. So everything is going to work. And the octocat API, for those of you who have never seen it, it's a GitHub provided API that when you call, returns an ASCII version of the octocat, which is our mascot, with a sentence from the Zen of GitHub, in this case, designed for failure. This API is going to be called, and as I said, the results are going to be printed by the script. Okay, let's see what else we have here. So requirements.txt, very important. We have these two Python modules installed as the code space is provisioned. So everything is automatic. Black for formatting and pylint for linting. And as before, we have devcontainer.json and Docker file. They're part of the project, right? This is code that is inside of the repository, meaning it's going to appear here as well. And you can also, by the way, make changes on these files and spawn a new code space, which is already going to contain, which is already going to be provisioned according to the changes you've made. Okay, so let's actually now go ahead and run this octocat.py script. And the nicest way to do this is by using this task, which I mentioned earlier, this launch task, which is going to start the Python debugger and then run our script and stop at the very beginning. So let's do that by switching to the run view. And as you can see at the top here, there's already the launch octocat.py task. If I click the play button here, so the debugger kicked in, stopped at the very beginning of the script, and this gives us the opportunity, for example, to say, I want to put a breakpoint here, and let's jump into that step. So now on the left side, let me increase this a little bit so you can see. You already see, for example, variables in the script, including HTML. It's going to be a little bit hard to read this because there are a bunch of new line characters. If you hover over HTML, you can also see that. And as you can see, the other variables are present there as well. So the debugging experience is also very rich and very powerful. And let's finish running the script and see what happens. So on the terminal, you get the octocat with a sentence designed for failure. And really the message here is, with zero setup time, I managed to get an edit environment, which is very complex already. Right? Visual Studio Code is a pretty rich, very powerful editor. And in here, I could do things such as changing my files. I could initialize the debug session. I have plugin installed out of the box and so on. So with that said, I will switch to another code space. And this one is going to be based on Jupyter Notebook. So we're going to have an actual Jupyter Notebook running inside of the code space to show you that the integration with Visual Studio Code and Jupyter Notebook is pretty smooth. And if it's a very, very pleasant experience to use both together. So let me switch to the other code space. Just give me a moment. Okay, so this is the third code space that I'll show you today. And this one I didn't design myself. Instead, I took it from this repository here from Microsoft. So if you go to Microsoft/VS Dev Containers, there is a long list of code space definitions which you can use in your projects directly. So I went to the containers directory. And then, as you can see, lots of programming languages and different use cases are available here. And I chose this one, Python 3 Anaconda. As the title suggests, this is a code space that is designed for developing a Python application. And it already comes with Anaconda, so you can use the conda command to manage your Python environment. And the instructions are pretty nice. They explain how this thing can be used. If you want to improve or make changes, it also gives you some hints if you want to do further configuration. It also installs Node.js, but we're not going to use this today. And at the very end, this is an important piece of information here. If you have an environment.yaml file in the root of your repository, conda is automatically going to install all the Python modules that are listed there. So you can use that to further customize the code space. Okay, so again, I did nothing but copying these files here into my repository. And in case you wonder where this is, it's within the complex branch of that repository I used before. So I copied all these files and just edited the environment.yaml file to really define the code space that I need for this particular applications that I want to show you now. So let's go back to the code space and see what's in there. So first, .dev container, as you can see, a lot more stuff than we had previously. Dev container.json now is also somewhat longer. The base.docker file is used to provision the code space container, and we can see a bunch of settings here for Visual Studio Code. Most of these settings are instructing Visual Studio Code to, for example, use the Python binary that is installed by Conda, and also things such as AutoPep8 or PyLint. All of these things are installed by Conda itself, meaning we have to instruct Visual Studio Code to use those binaries instead of the system binaries, right? So extensions only Python, and that's about it. Let's go to base.dockerfile and see what's in there. Okay. So in there, we see that there are a lot of commands. I'm not going to go over all of these, but I want to point out that at the very bottom here, we copy the environment.yaml file into the container, and then conda uses this file to install further packages for you. So further Python modules, really. All right, so this is going to take a while to load because there's so many commands being executed. However, for this particular project, if you go to the README, it will tell you that you could use, for instance, Dockerfile instead of base.dockerfile. And here, an image is already pre-built for you, so you don't have to go through all those build steps inside of base.dockerfile. This is going to significantly speed up the provisioning of the code space. All right, that's about it. One last file that we have to see is environment.yaml. So this file really is the only file that I have changed, that I have introduced in this project to customize the code space according to my needs. And as you can see, it's pretty simple. I am essentially telling Conda, please install these 2 Python modules and nothing else. So TensorFlow and Keras, because we're going to use this for a data science study inside of the Titanic directory. But before we get to that, let's look into the test project directory. I did not create these files. They also came with the code space, so we can actually use them to test if the code space is working correctly. And in hello.py, you can already see, for example, matplotlib and numpy be utilized. I didn't install them. They already are installed automatically for us. And what does this do? It defines some x values or some values along the t-axis, and some y values. So a sine wave, which we're going to then plot and store into a file. And that's all the script does. So in order to execute the script, I will go to the run view and then click the play button. So now you can see that a terminal session was initiated, and within this terminal session, Conda activates the base environment, which is a necessary step because the script needs to know where to find the modules that it requires, and Conda has installed this module, so the environment, the Python environment, is managed by it. That's why we have to activate it first before we run the script. But the nice thing is, this is done automatically for us. I didn't have to do that step. At the very end, we have an instruction here saying that test project / plot.png is where the result is placed. Let's go and see that file. So there we go. Let me close this. Surprise, surprise, it's a sine wave. We already knew that, but it's still nice to see it inside of Visual Studio Code. So this is just a test script, and we are at this stage convinced that the environment is properly set up. Let's now move to an application which I have written. So it's a Jupyter Notebook, as I've mentioned earlier. So let's go and open that one. All right, I've skipped a couple of steps here just to make things a little bit faster on this presentation. But essentially, when I opened titanic.ipynb, I was shown a pop-up asking me to trust this notebook, which of course we do because, well, I wrote it. And the Jupyter server was initiated automatically for me. I didn't have to do this step. The connection is done automatically for me. And you can see, for example, here, this is Markdown. And Jupyter server already parsed all of the Markdown in this file. And it's showing, for example, things as titles. So everything looks quite nice. I won't go over every step here in detail, but a quick overview can help us understand what's going on. So for example, I'm importing pandas and numpy. Pandas means we're going to use data frames. And throughout the script, we work on the columns. We are going to plot the data. So let me quickly execute this so you can see exactly what this looks like. Give it a couple of seconds to run. Okay, and at this stage, we're going to plot some of the data. And the nice thing is that the resulting plots are going to be appearing in line here, and we can go inside and browse through them. So for example, if I double click, I can, for instance, look at one of these plots. Oh, this is a nice one. So survived versus class. And you can see, for example, the survival rate is very low for males compared to females. And the lower the class, or numerically speaking, the higher the class, because third class is technically higher than 1, the lower the survival rate, right? So if you were in first class, your chances of survival were better, were higher. So let's go back to the script. And I'll just go and step through everything here. We compute some correlations between survival rate and some of the features that are, or the attributes that are given in the data set. And so you can see, for example, that gender is the one that correlates best with survival, which also is what we saw in this plot, right? So we do a little bit of playing a little with the columns. I'm not going to go over this because this is not so important, but the interesting stuff now is coming. We're going to actually keep only some of the attributes that we believe are the best for training a model, and we use naive Bayes to train the model, first by splitting the data set into the test portion and a train portion, which is what we do here, and initialize the model. And at the very end, we use the test data that we have separated to check the model's accuracy. So by doing this, we can see, for example, it's 74%. Well, not bad. For such a simple model, it's actually already quite interesting. And the second model is more interesting because it's actually using the Python modules that I've installed here. So if I go back, you can see that it's using Keras, and we're going to define a model here, which is based on a neural network, a layered neural network. And at the very end, we're going to check the accuracy of that model compared to naive Bayes. So give it just a couple of seconds to load all of these modules and do the module initialization. And I'm on. You can do it. Go, go, go. This is taking a little bit longer than I was expecting, but it's going to for sure be done in a second. Hello. There you go. Okay, so everything is done already, and now the module is being trained with the training set, and it's over. Now let's go and check if the accuracy is better. 77.9%. Okay, about 78%. Not a lot better, given that this model is significantly more complex than the previous one. But anyway, it was still fun to go through this. I hope you can appreciate how easy it is to work with Jupyter Notebook inside of Visual Studio Code, and that we pretty much didn't have to do any setup again. So no setup time for this code space. I essentially opened it and executed my application. And of course, I can make further changes here and run. I could install additional Python modules if I want. The environment is really yours, and it's a discardable environment, meaning if something goes wrong here, if I break something, no need to be stressed about it. Throw this code space away, initiate a new one, start from scratch, and do your changes correct your changes this time. So the last code space I want to show you today is for a very complex application that we have. So this is already, you could say, enterprise level. And it's a bookstore written in Java, where we have Kubernetes for deployment. We use Terraform. There are even multiple containers because this application uses a PostgreSQL database. So let's take a look at some of the files very briefly. We have now Docker Compose instead of Docker. Again, because we're using multiple containers, we specify one of those containers. It's going to be called app as the code space one. We use port forwarding so we can access some of the some of these containers from the external world. Lots of extensions are installed, including for playing with the SQL database, and we even set some settings for that extension here. So as you can see, it's a very, very powerful code space. Docker Compose.yaml shows us a little bit more. We have the code space container being defined here, and we don't build it manually this time. We actually pull the image directly from the GitHub container registry. We have an external project which builds this image for us, and here's the database container, right? The last thing I want to show is the fact that you can connect to a code space running on GitHub directly from your local installation of Visual Studio Code. So you may want to do this, for example, because the keyboard shortcuts will not interfere with the shortcuts of the browser, for instance, or maybe you just like the experience better. So to do this, you need to install the Visual Studio Codespaces extension from Microsoft. And now when I go to the remote view here, I can connect to my code space. This is going to be the one that we were just looking at. And the editing experience will be really live in the sense that if I make changes here, they're going to appear on the browser and vice versa. So give it a couple of seconds so you can see that I'm actually telling the truth. There you go. So we can already see the dev container.json file. With all that said, thank you very much for being here. I hope you're going to enjoy Codespaces as much as I do. And if you have questions, you're always welcome to send me an email at Assencio, as in my last name, @github.com. So thank you once again for being here, and take care.